Hi everyone, how are you doing? I hope you're all fine. My lovely students, today I am going to review another subject, page 153. Subject: How stars are classified. Star magnitude. At night we can see thousands of stars, but during the day we see only one star. It is the sun. The sun is so near that its brightness keeps us from seeing any other stars. The sun is so near of the earth, and that its brightness keeps us from seeing any other stars. As you learned in the investigation, how bright a star looks depends on two factors. Number one, its magnitude or brightness, same means don't difference. Or number two, it is distance from Earth. Or question: why do stars have different apparent magnitudes when viewed from Earth? Apparent magnitude when viewed from Earth. The answer of this question is that number one, its magnitude or brightness, or number two, it is distance from Earth. Number one, its magnitude. Number two, it is distance from Earth. Do you remember, my pupils? I talked about this question in the class. Suppose two stars that produce the same amount of light are different distances from Earth. They seem to have different magnitudes. The more distant star looks less bright when viewed from Earth, so its apparent magnitude, or how bright it seems to be, is less than its absolute magnitude, or how bright it really is. This star has a greater apparent magnitude than the star below because it is closer to Earth. This star has a greater absolute magnitude than the star above. However, since it is farther from Earth, it looks less bright. My pupils, do you remember this question? What is the difference between absolute magnitude and apparent magnitude? This question very, very important. Please try to pay attention to this question. Absolute magnitude, it is really bright, but apparent magnitude, it isn't really bright. The brightness of a star, as seen from a distance of 10 parsecs, real distance, this is absolute magnitude, but this is apparent magnitude. It isn't really bright. Do you remember, my pupils? This subject very important. Please watch this video.
Throughout history, astronomers have performed various methods of analyzing the apparent magnitude of celestial bodies. Variables such as size and color have been recorded for generations, but much of the data, if not all, was worthless in reference to a scientific study. This need for specific, replicable data led to the definition of what we now know as a star's absolute and apparent magnitudes. There are many reasons why a star looks the way it does. Stars evolve and can even be manipulated by other large-scale forces, causing changes in shape, size, and color. These changes can happen in days, as in the case of SN 1074, or can take as long as millions, if not billions, of years for a full cycle to complete. These fluctuations can be analyzed giving an estimate to how much energy a star consumes, which, generally speaking, if a star is burning more energy, it should appear brighter in our night sky. But why is this not always the case? First off, what is absolute magnitude, and how does it compare to a star's apparent magnitude? Simply put, absolute magnitude is defined as the measurement of all forms of light waves coming from a celestial object as seen from a standard distance of 10 parsecs. While apparent magnitude is defined as the measurement of all forms of light waves coming from a celestial object, visible from Earth. What this means is that if a bright, or luminous star is far away from Earth, it will have a high absolute magnitude. But, because it is far from Earth, it may appear dim, therefore having a low apparent magnitude. The reason the star would have a high absolute magnitude is because it is a bright star, making it very bright at a standard distance of 10 parsecs. The reason why the star would have a low apparent magnitude is because it appears dim while viewing it from Earth. Another example to consider, if I am viewing an extremely bright star from Earth, and I also know that the star is relatively close to the Earth, then would the absolute and apparent magnitudes be high or low? Let me know what you all think in the comment section below. One fact about our Sun is that it exists approximately 93 million miles or 1 astronomical unit away from Earth, and has an absolute magnitude of 4.83 and an apparent magnitude of -26.74. It also takes exactly 648,000 times pi astronomical units to equal 1 parsec, meaning a parsec is a massive distance. The distance of 10 parsecs was chosen to allow astronomers a viewing distance that could be applied to any star in our known universe. For instance, if you were 10 parsecs away from one of the largest stars in our known universe, Betelgeuse, which has a radius of 5.5 astronomical units, you would see a bright object glowing with an absolute magnitude of -5.85 compared to its apparent magnitude of 0.42 here on Earth. This distance to the star, approximately 3.26 light-years, are roughly 3/4 of the distance to our nearest neighbor from Earth, Alpha Centauri, also gives a more relative standard to the star's brightness rather than basing it solely off of other variables such as color and size. One common misconception about absolute and apparent magnitudes is that they only apply to the Sun and stars, however this is not true. The luminosity of celestial bodies is constantly analyzed in terms of absolute and apparent magnitudes whether for a comet or any other celestial object. There you have it, the difference between absolute and apparent magnitudes.
Okay, my students, it was a useful lesson. See you next lesson. Goodbye.